In this sandbox, we solve a system of nonlinear equations. Let's take a look. Here we have two equations. The first one has three terms on the left-hand side, one term on the right, a constant 1. Each of the terms on the left-hand side is quadratic. Second equation as well contains quadratic terms on the left and a constant on the right. Instruction says to solve this system. And then nicely, this picture here represents graphs of each equation. Spend some time thinking about which equation corresponds with which graph. The green graph here is an ellipse, where it nicely has a horizontal major axis, a vertical minor axis. The blue curve also looks like an ellipse. However, it is oriented on a shifted major axis. All right, see how well you do in working that problem? If you'd like some hints, stay tuned. Let's go over step by step, three parts on how to solve this. First part, let's take the equation x squared plus 5y squared equals 2. Let's isolate out the x squared. Now that we have a quantity x squared isolated, we can figure out what x is by taking the radical of both sides. Don't forget that on one of the sides, you'll introduce a plus minus. Now that we have an expression for both x squared and for x, let's take these expressions, which will only be in y, and plug in to the other equation. X squared plus x product y plus 2y squared equals 1. Substituting in will eliminate out the x's and produce a single equation in y only. However, when we plug in for x, we're going to find that that is going to yield a radical term. So next, let's isolate out that radical term. And then if we square on one side, we square on the other side, we can come up with our next equation. Good. Part 2. Take the last equation that we had and bring everything to one side. In other words, set it equal to 0. As you look around, you should see that the equation on the left here is quadratic in y squared, for which you can use the quadratic formula to determine what y to the power 2 is equal. These will be hard values. You can take these hard values for y squared and you can plug it into the first equation, or the first equation we worked with, x squared plus 5y squared equals 2. Since these are hard values, we now have an equation for which we can solve for x. Solve for x. Excellent. Now the fun part. We have expressions for y squared. We can figure out what y is. We apply a radical to both sides. That's going to introduce pluses and minuses. We also have the same thing happening here for x's, pluses and minuses. Then what you want to do is you want to use as reference this picture, the sketch of the two curves, and notice where they're intersecting, and figure out the coordinates of these 4 points. Very nice.